Hi everyone, I'm Cheryl. In this problem, we're going to be using the ratio test to see if my series, which is the sum from n equals 1 to infinity of 9 to the n all over n to the fifth, converges or diverges. Now, in order to use the ratio test, we have to make sure that all the terms are non-zero. And in fact, if you look at 9 over n divided by n to the fifth, all of those terms will be non-zero. So what we're going to do by the ratio test is take a look at the limit as n approaches infinity of the absolute value of a sub n plus 1 all over a sub n. It turns out if this particular expression is greater than 1 or infinity, the series will diverge. If it's less than 1, it will converge. And if it equals 1, the test is going to fail. So let's see what happens in this case. I've got the limit as n approaches infinity of the absolute value of a sub n plus 1. That will be 9 raised to the n plus first power all over n plus 1 to the fifth power. And then I'm going to divide that by a sub n, which is 9 to the nth all over n to the fifth power. Okay, that gives me the limit as n approaches infinity of the absolute value. I'm going to take this compound fraction and invert and multiply. So I've got 9 to the n plus first all over n plus 1 to the fifth power times n to the fifth all over 9 to the nth power. Now I notice here that I can cancel 9 to the n and 9 to the n plus 1, and I'm left with just a 9 here. And the other thing I'm going to notice is that all the terms inside that absolute value are all positive. So I really don't need the absolute value signs for this particular problem. So I have the limit as n approaches infinity of 9 n to the fifth all over n plus 1 to the fifth power. And as n approaches infinity, I can see that this particular fraction is going to equal 9 over 1. Or 9, which is greater than 1, which tells me that my series diverges. I hope that was helpful. Thanks.